Hello everybody, get ready to do lesson 2.4 of Algebra 2 Math, part 2. Today part 3 is available at this email here, and 2.4 part 2, and we got a 38-point skill sheet today for classwork, and then 7 points here for notebook. And for today's lesson in your notebook entry here, quadratic form of an expression of this form here, AUB squared plus BU plus C, where U is any expression in X, is said to be in quadratic form. The factoring techniques you studied in previous chapters can sometimes be used to factor such expressions. So quadratic form, students, in your own words, define quadratic form. 5 points, your notebook. And this page and the prior page should go in your notebook. I do my notebook checks on Friday in my classroom. Other teachers, that's up to you when you check your notebook entries for your students. Alright, example 4, factoring polynomials in quadratic form. Factor completely. We have this situation here. So how are we going to factor that in quadratic form? We're going to factor out a square here, 9. Factor out take a square root basically of each one of these members here of this expression. You get 4x squared minus 9 squared. This is a difference of a square, and then you follow the pattern there, difference of two squares, and you come up with this expression here for that. And then difference of two squares here, so we have a 2x plus 3, 2x minus 3 here, and then we got 4x squared plus 3. So that's what that factors out to being. Then factoring polynomials again in quadratic form, factor completely. So we have this situation here. How will we factor that in quadratic form? So we have 2p8 plus 10p to the fifth, 12p squared. We can factor out a 2p squared here, and we get this expression here, p to the 6, 5p cubed plus 6. So we factored out a common monomial, which is 2p squared. And then this here, we factored a trinomial in quadratic form. So we have p cubed plus 3, and then p cubed plus 2. Is how we can factor this trinomial here. And that's how that would be. So we're using basically two binomials in a prior term. So let's factor this polynomial completely here. Students, this is yours. Pay attention so you can do your independent practice. So let's do our first. So factor this polynomial completely, 4t to the 6th minus 20t to the 4th plus 24t squared. We can factor out a 4t squared out of this trinomial, and we end up with this. So now we can factor this trinomial into two binomials. This is basically what we're going to do. T squared minus 2t squared minus 3 is what we're going to turn this into, this trinomial here. Solving polynomial equations, you've learned how to use zero product property to solve factorable quadratics. You can extend this technique to solve some higher degree polynomial equations. Okay, into our next example here, example 5, standardized test practice, kind of a format here. What are the real number solutions of this equation here? 3x fifth, 15x equals 18x cubed. What are the real number solutions of this? Well, how do you find that? Write the original, and then we're going to put it in a standard form here of all this to equal 0. And then we have this situation here. We can factor out a 3x out of it. Then we end up with a trinomial here that we can factor into two binomials. And then now we can kind of find zeros now for this. X squared minus 1 is the difference of a square, and this will factor into this. Then we have x squared minus 5. So we're getting closer to finding zeros here. So x equals 0 would be one solution. x equals -1, x equals 1 for this, and then x would equal the square root of 5, or x equal the negative square root of 5. This would be the possible solutions for this expression here. So the correct answer would be D in this situation. And that might be something you see on a SAT as well. Okay, find the real number solutions of this equation here. Students, this is yours. Pay attention so you can do your independent practice. Find the real number solutions of this equation right here. So we're going to factor out a 4x, and we end up with this trinomial here. And then we're going to factor this into two binomials here. Here we have a difference of a square, and we have a difference of a square here. So we can have an expression here developed from that. 4x minus 3, x plus 3, x minus 1, x plus 1. So we're going to have like these solutions here for this expression here. X equals 0, x equals 3, -3, 1, and -1. These are our possible solutions for this expression. Into example 6, solve a polynomial equation. You are designing a marble basin that will hold a fountain. The basin sides and bottom should be 1 foot thick. Its outer length should be twice its outer length should be twice its outer width and outer height. So, what should the outer dimensions of the basin be if it is to hold 36 cubic feet of water? That's quite a question there. So how do we solve that? Volume equals interior length times interior width times interior height. So we know it's got to be 36. And then our interior length here will be 2x minus 2. So basin side, outer length should be twice its outer width. And then our width will be x minus 2. So this is 2x will be its length, and then x will be its width. And then its height will be x minus 1 as well. So your length is twice its width and twice its height. So there's our verbal model, and then we put this all together, and then we multiplied this together, and this is our standard form of that area, or rather our volume polynomial. And then we factor out a 2x squared out of this situation, and then this situation here, then 10x, we factor out a 10 out of these two. So we factor by grouping here. We end up with that. And then we have a distributive property here, 2x squared plus 10. We group these together here, and then x minus 4. So the only real solution in this situation would be 4. The basin, therefore, you plug that back into the original, and you'll get the basin is 8 feet long, 4 feet wide, and 4 feet high. That would be the way that you would solve it for 0. And into our next guided practice, in example 6, what should the basin's dimensions be if it is to hold 40 cubic feet and have outer length of 6x, a width of 3x, and a height of x? So we'll use the last example. And then students, this is yours here. Kind of like the same problem here, but with a little bit different situation. Pay attention. So for example 6, we change our dimensions here. We have a different model. This was the old model here, and then this is our new model here for 40. So we're going to go from here to here because we have a change here, 6x and 3x instead of 2x and x. And then x minus 1, we keep this the same. So this is our new model here for new dimensions. Then when we multiply out, we get this situation here, 40 equals that. We move our 40 over to the other side, we get this situation here. We factor by grouping here, 18 out of these two terms here, and then factor out 22 out of this, we get x minus 2, x minus 2. And then we put together 18x squared and 22, and then we have x minus 2. Here's a solution here. So when we do that, the only real solution in that situation is 2. So therefore, plugging that back into the original polynomial, the basin will be 12 feet long, 6 feet wide, and 2 feet high. And that was lesson 2.4, part 2. And I think that's only a 2-part lesson. You got both parts there. If you need class worksheets or homework for that, email me here and I'll get those out to you. Thank you.